Okay, for this next video, what we're going to do is we're going to have a look at how to find the maximum or the minimum values for problems in a practical context, and we can determine the interval for where a function is increasing, decreasing, and then we'll find the value where a rate of change occurs. So let's have a look at CAS. Now whoops, that's not CAS. This is CAS. So what we're going to do, we're going to have a look at question 3 from exercise 13.6. That's what we're having a look at. Now that talks about the paddock. So we found that with that, we ended up with an area of a paddock. So we're going to define this now it's A of W. We'll just remember when we're graphing things, we just remember A of W equals 40W plus 2W squared. So that's what we've got there. Now I'm going to change that and make it A of X. So define A of X equals 40x 2x squared. It should be okay. So now if I type in A of X, 2x squared plus 40w, it should be a negative. Okay, so now we'll try it again. A of X, and that's fine now. Alright, so what we're going to try and do, we're going to try and find the maximum or minimum for this. Now I know that this, because we've got a negative x squared, is going to create a negative parabola. So what we're going to do is we're going to differentiate this. So we're going to say calculus derivative. We're going to say dx of ax, and it tells us that. So we've got that derivative. Now we're going to say solve that equals 0 for x. So it tells us that the turning point is at x equals 10. Then you can say a 10 is at 200. So we'll say that our maximum happens at 10, 200. How do we prove that it's a maximum? Well, that's where we've got to choose a little bit below and a little bit above. So we'll choose, we know that our maximum we know that our turning point is at x equals 10. So we'll do at x equals 9. We've got 198. Oh, sorry, not that. We do our derivative. So what we're going to do is we're going to define the derivative. So define a dash of x equals, that's our derivative. So a dash of 10, we know it's 0. A dash of 9 is 4. A dash of 11 is negative 4. So that tells us, so we've got positive, 0, negative. So that tells us that this at 10 and 200, it's a maximum. So that's how we find that it's a maximum. Now, how do we find out where a function is increasing or decreasing? Well, we know that a function is increasing if our derivative is greater than 0. So what we do is we say solve a dash of x being greater than 0 for x. So what happens where x is less than 10. So that's where it's increasing. We want to see where it's decreasing. It is where it is less than 0. Remember, it doesn't include 0. So that tells us here that it's also at 10. Okay, let's say we want to find where the derivative is equal to 5. So what we do, if we want to find where the derivative or rate of change is 5, that's what we want to try and find. So what we do is we say solve x, sorry, a dash, there goes the bell. So we say solve a dash of x equals 5 for x. That tells us that it happens at this value of 35 over 4. That's when we have a rate of change or a derivative of 5. That happens where x equals 3514. So just to take you through those and what we've covered, here we've got the maximum minimum value of problem within a practical context, where a function is increasing or decreasing, and we can determine where a rate of change occurs. So let's have a look. So we'll just go through those here. So here we've got our area. So that's our practical context. We found our equation for it. There it is. We're finding the derivative. That's our derivative. We're looking for a turning point. So we solve for where it equals 0. It tells us it happens at x equals 10. To find out if it's a maximum or a minimum, we find a value to the left and to the right of our turning point value. Positive, 0, negative means the maximum. If it was negative, 0, positive, then it's a minimum. We want to find out where a function is increasing. Well, that's where our derivative is greater than 0. We want to find out where a function is decreasing. That's where our derivative is less than 0. We want to find out where our derivative has a particular rate of change. Or we want to see when the function has a rate of change, or whatever the case may be, we let our derivative equal that and we solve for x. They're the steps that we take.